to make sure, and that's of course an operating system problem, that different compute threads cannot influence the memory of others if that is not allowed. So, so what about banked memory? So what do we have here? We have, say, 512 kilobit or byte. Anyway, so I would say byte memory on a 16-bit address bus. So 512k is 2 to the power 19. So I need 19 address lines from 0 to 18. But I have a 16-bit address bus. So effectively, I need 3 more address lines. So, well, we need to just use a latch again, meaning that we are going to use those 16 lines to those 16 address lines to be connected to, for example, to be transmitting, say, A0 up to A14 in this particular case. And you have another 4 bits coming from this latch. So what happens here is that you use those address lines directly to feed into your into your RAM for the first 15 address bits, but the last 4 are actually been given over your data lines. So you use those data lines to sometimes transmit actual data, or say the A15 to A18. So that's what you would do. So it's kind of a multiplexing in a different type of way. Anyway, you can imagine there's lots of solutions. You just have to use your output lines for multiple purposes. And that is important. And that's what we're going to learn here in this lab as well. All right, let me go to the other slide deck, which talks about the lab assignment, so that we're all on the same page. And so what do you guys need to do? You need to connect your SRAM to your to your Atmega processor, and this is what you would like to have. So you would like to do some multiplexing. So you have lines that are both carrying address information and data information. To this purpose, you will be using actually 2 latches over here that store the address information of the first 8 bits, and here the last 8 bits, or 7 bits, sorry. So your SRAM is I don't know, is 16 kilobyte probably. I'm not sure, but anyway, it's this number. Actually, how much is that? Yeah, something like that. Yeah, 16 kilobyte. Okay. And so what do you see here? So first of all, we only want to use 8 pins. So we want to multiplex, effectively all the address and data information together over those pins. Why do we want to do this? Because otherwise we do not have that many pins left. So we really want to be very careful and really want to just use 8 pins and not more, because all the other pins you will be using for your OLED, for your joystick, for your Bluetooth, and you obviously want to connect to your UART as well, so that you can see what's going on. All right, so that's what we're going to do. So first of all, you do have your read and your write control lines. You still need those for your SRAM. Then I need a latch enable for 0 and for 1, so that's 1, 2, 3, 4 control lines. And then I need another 8 lines that carry both address and data information. So that's what we are doing here. So effectively, latch 0 carries the lower 8-bit addresses, latch 1 the 7-bit addresses, and once we have put out all the address information, we can let by controlling the SRAM through these control lines, we can let it know that the address information is available, and then we can and in the meantime we can also put the data out that needs to be written, for example, or it will output the data that I'm interested in because I want to do a read. So this is the basic structure, and if you look at the specific layout, this is what you actually are doing. So here you see your microcontroller again, so it's all on the slides, right? So the details, it's hard to read from that from a distance, but you can see here that we have, for example, here we have this. Let's have a look. So so we have these D0 to D7 are connected to these particular pins over here, and those two over here. And then we have the latch enable and the other latch enable are separate lines, as well as those two. Those are the control signals that we also need to work with. So those are the two, and they come in over there. So we really use quite a lot of pins, by the way, already. So that multiplexing is really necessary. So this is what it would look like on your board. For example, you do whatever you want to do yourself, of course, but this is how we did it. So anyway, so do that. So we have the SRAM. Oh wait, I was wrong. So 2 to the power 15 is of course 32 kilobyte, because 32 is 2 to the power 5. So yeah, so 32 kilobytes you can store. So we're looking here at the MCU pins. These are the pins that form the address and data bus to transfer address or data information between the MCU and SRAM. And we split the port since PD0 and PD1 are used for UART, so that's why we don't want to use those two pins. So that's always a battle, right? If you need to know your processor, you need to know what those pins all mean, and then you know which pins in terms of your larger vision you can actually use, and so in this case we use those. So we have an active low chip enable, that's the PD6, and that's and you have the output enable, and then you have a write enable. So is that it? So then if you look at the write cycle, again you need to look at those data sheets, very important. I think this is in your SRAM data sheet. You will see what is happening. So first of all, again, you want to give the address information, and at some point when the address information is it's going to be read. So it's kind of hard for me to see now, but you will indicate with that CE signal, I think. And then at some point you want to, for example, write something, and in the meantime you want to make sure that the data is actually in there and is valid. So that's over here. Once the data is valid, you go up here, and then you can actually write the data. So you have to look at this sequence. Right now I'm also studying this data sheet myself, but you want to go through these steps yourself. So what do you need to do? Well, you need to apparently go through the sequence. So the address information gets on. You need to make this control line go down, then this go down, and this go up, then this goes up. And in the meantime, at the right moments, the data needs to be validly available over those pins that the SRAM expects. Or it will, well, if you look at the read cycle, it will be the other way around. Then the data will be coming out and you're ready to actually read it. Now, so let's see, so want to make sure. Okay, so okay. So let's have a look here. So here we have the latches. Again, we use those pins for the address and data. We use two latches. One latch will hold this part of the address, the other one the higher order bits. You have a latch enable, and I'm not sure which bits, which pins we use for those, but that should be somewhere. Is it over here? No. Okay, you can ask me. It should be somewhere. So here we have the timing diagram abstractly for a write with the latches. You first write the address information. So the latch 0 gets it, then latch 1 gets this. Then you are ready. So now you can put the CE signal down because the address information is available. In the meantime, you also have the data coming in, right? So then you can do the write by pulling this down here and pulling this up here. So I'm not so sure about the order of these two, by the way, now that I look at it. But that's something you may want to figure out. And for the read is something similar. So you have address information. Once those are settled in the latches, you will pull this CE down, which means that the address is being read by the SRAM. It transmits the D over here, and then you will be able to, the data out there, and then you will be able to read it. So, what are these lab assignments? So effectively, task 1, you're going to create a write functionality. So you write something. In this particular case, you put in a 16-bit address, but again, you only use 15 bits of it, right? Here interpreted as 15 address bits. Task 2 is to read something. Then task 3, you're going to check it. You're going to, for example, test it, but you're testing it. You make sure it works. And you want to demo that, of course. And if it all works fine, that's great. Then you can create your own library with the SRAM write and the SRAM read functions. And that can then be used as a library in your final project. That's the goal. Now, this is pretty much what I wanted to talk about. And then next Monday, I'm going to go over these slides again, and I will share some thoughts about the solutions that we have, so that you can think that through a little bit more. And yeah, so I guess I have some solution code in here too. But yeah, let's do that later. So this is kind of enough. So let's stop here. So think it through, and then we can talk about it. And then also during the lab today, but some of you are still working on a CAN, or maybe all of you actually. And then next week we can sort of repeat this part, and we can look more at the solutions that we have. Then hopefully, everything starts to sink in, and you can work with this. Yeah, I have a question. Yeah. Okay. Yeah.